All right, now, let me make a comment. In the beginning of these questions, the method might seem like it's overkill. And many of you can just see the answer coming. Or you just try a number until it works. Don't do it. You need to learn the process. Because as the numbers get uglier and uglier, the chance you have for guessing the answer or seeing the answer gets less and less. So even though you think you have a method that works, it probably only works for easy numbers. So you need to learn what I'm going to share with you. Okay? Up to you. All I can do is try to guilt you into doing what you're supposed to do, like threaten you. Now, when we talk about a solution, very simple idea. We're looking for a number that works. So, we have 3 times something plus 1 equals 3, right? We said earlier, whenever you have a variable, and we're going to plug in for that variable, let's use parentheses. It says here, determine whether -1 is a solution, or if it works for y. So I plug in -1 for y, and let's see if it works. What's 3 times -1? Copy everything else down. What's -3 plus 1? Is that the same thing as 3? No. Therefore, -1, what? Doesn't work. And in the words we have here, -1 is not a solution. So the meaning of solution, look for a number that works. Now, like I said earlier, these problems are going to be easy. And you can probably look at that and figure out the answer. But as time goes on, you won't be able to do that. So here's the goal. I want to solve for who? X. So at the bottom of this problem, I want to have x equals a number. Right? If I can do that, then I can tell you what x is. So here's the idea. Let's rewrite the question. And conceptually, let's think of this as a seesaw, or a teeter-totter, or whatever else you call this thing. Okay? An equation is balanced. If you put something on one side, how do you keep it balanced? Same thing on the other side. Okay? That's what the concept of what we're going to do. So, here's the idea. Since my goal is to get x by itself, well, I look up here and I go, that -2 is in the way. Okay? So, if you spend $2, how do you get back to where you started? Add $2. So let's add 2 to both sides. Is my scale still balanced? Yes. What's a -2 and a +2? It's 0. What's -1 and 2? 1. Now I know. I don't have to write the 0. But I write it for a reason. I heard the C word. I hate the C word. Canceling is the worst thing in math you were ever taught. Because you will do these crazy things and call it cancel. Some people put this over negative 2 and cross it out. Bad, bad, bad. The idea here is if I can make the number next to x 0, what happens when you add 0? You get x by itself equals 1. Done. 1 works. Let's try it. Put 1 here. What's 1 minus 2? Negative 1, it works. Solving is looking for the number that works. But we are not going to use trial and error. We're going to learn to isolate the variable. And that's going to be our approach for all of these. Okay? And probably you remember that from any algebra class you have ever taken. That is always the goal. Isolate the variable. And it doesn't matter which side the variable is on. Okay? Now, how can I get the n by itself on the right side? Subtract 1. And some people like to subtract 1 below. That's fine. What's 1 minus 1? 0. Good. You didn't use the C word that time. And what's negative 8 minus 1 more? Negative 9. Someone said negative 7. Isn't that negative 8 plus 1? But this is negative 8 what?
Minus 1.
Minus 1. Be careful. Now, here I have a small problem. I have the variable on both sides of the equation. What's my goal? Isolate it on one side. Isolate it on one side. Now, to deal with this, yes, you have to work with both sides. So, here's the idea. What if I say, let's get the variable on one side? So choose. Which side do you want the x on? Right now it's on both sides. Which side do you want it on? Left, okay. If you want it on the left, then it can't be on the right. How do I get rid of the 6x on the right? Okay, now, someone said divide by 6 because of the cancel mentality. Bad. The 6x is attached by addition. Division ain't going to work. But can I subtract 6x from both sides? Right, actually, let me show you this. Let me show you this. Don't write this down. This is wrong, 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 and wrong. Okay? Someone said, oh, divide by 6x. Watch what happens. What's 6 over 6x? 1. And we have 1 plus 4. It's not gone. It became another number. Bad news. On the left side, what's x over x? 1. And so we have 7 over 6 times 1. Bad news if you divide by 6x, isn't it? You're seeing that 7 over 6 is 5? Yikes. So don't do that. But I went there because someone said it, and I want to address it because I'd rather you not make that mistake. Anyway, ready? What do we see instead? Subtract 6x from both sides. Now watch. What is 7 apples minus 6 apples? 1 apple. What's 7 stars minus 6 stars? 1 star. What's 7 books minus 6 books? 1 book. What's 7 x's minus 6 x's? 1x. What is 6x minus 6x? 0. In the previous approach, you had a 1 there. Didn't really get rid of it, did it? Okay. And so what's 0 plus 4? And what is 1 times x? Did I isolate x? Yes. Now, in example 5, we want to isolate who? X. Who's with it? Negative 5. Now, how is the negative 5 attached? Multiplication. Did you notice in the previous examples, when something was attached by addition, we subtracted? What do you think we're going to do if something's attached by subtraction? We're going to add. If something's attached by subtraction, we're going to add. We do the opposite operation. In this case, we have what again? Just say it. Multiplication. What is the opposite operation to multiplication? Division. So I'm going to divide both sides by negative 5. Now, watch. We are not going to use the C word. What's a negative 5 divided by a negative 5? 1. What's 15 divided by negative 5? If that 1 were a 0, I'd lose the x. Because what's 0 times x? 0. I don't want to lose the x. I want to isolate the x, right? So if I have multiplication here, I need the number in front of it to be what? 1. Because what's 1 times x? Is x isolated? Yes. So here's the idea. When we're adding and subtracting, I want to make a 0. Because what happens when I add 0? Nothing. What happens when I subtract 0? Nothing. If a number is attached by multiplication, I want to make it 1. But the problem that you've had in the past is you called all of those one thing. Cancel. Haven't you? Don't do that. Okay? In example 6, you do this. Isolate who? Y. Go ahead and try that. Okay? Who are we isolating? Y. Who do I need to get rid of? 3. How is the 3 attached? Multiplication. How do I undo multiplication? Division. What's 3 over 3? 1. No, you don't have to write the 1. It's what I call the teaching step. I write the 1 to show you what's going on. What's a negative 27 divided by 3? Negative 9. And so what's the right-hand side? Y. What's the left-hand side? Did I isolate the variable? So guess who y is? Negative 9.